Hey, welcome back, guys. In this video, we're going to talk about tree diagram, sample space, and lists, and it comes directly from a probability unit. So theoretical probability of repeated experiment can be represented by a ratio of the number of favorable outcomes to the total number of possible equally likely outcomes. A table, tree diagram, or organized list can be used to determine the number of favorable outcomes. Okay, so favorable is what you want. So that's over the total outcomes. I like to keep the definition simple. It'll make sense when we do some practice. So it says create a tree diagram to show the sample space of flipping a coin 3 times. What's the probability that all 3 flips land on tails? Okay, so on your first flip, this first set of branches is what I would call it for a tree diagram. The first flip, you can land on either heads or you can land on tails. Now, on the first flip, if you landed on heads, you can also land heads or tails on the second. It's not like you can't land on heads the second time. On the first flip, if you land on tails, the second flip, you're allowed to land on heads or tails. So right now, I've given only on 2 flips. It says 3 flips, so we're going to do it again. First time you can land on heads, and the first time you can land on heads, the second time you can land on heads, and the third time you can land on heads or tails. Now we're looking at the next one. You can land on heads the first time, you can land on tails the second time, and then you can land on heads or tails the second time. Now you can land on tails the first time, the second time you can land on heads, and then the third time you can land on heads or tails. One event doesn't affect the other. Then the first time you can land on tails, the second time you can land on tails, and then the third time you can land on heads or tails. So this is our tree diagram, but I'm going to go ahead and create an organized list. So the first time I could have landed on heads, and then the second time I could land on heads, and then the third time I can land on heads, which comes from here, here, and here. Now I'm going to go the first time land on heads, the second time land on heads, and then the third time I can land on tails. And then the next time I can land on heads the first time, tails the second time, heads the first time. So my next list would be heads, tails, heads. And then the next one would be heads, tails, and then land on tails again. And so hopefully it's making sense as I'm writing, you're paying attention. And then at the end you can pause and write what you need. So you can land on tails, then followed by heads, landing on heads, landing on heads. And then again, you can land on tails, heads, and then you can land on tails. This is definitely a very popular STAAR question, just so you know. And then when next sample space or our list will be tails, tails, heads, and then the last one could be tails, tails, tails. So now it's what are all the possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8. So 8 is the total possible. And then it said all 3 land on tails. So when you look at it, which one has all the tails? Well, it would just be 1. If you look at the list, it's easy to tell that only 1 out of 8 would end up with tails all 3 times. Now, this is just theoretically. It doesn't mean that if you actually flip it and then it will do that. This is just what should happen. So it's theoretical probability. You actually flipping a coin, that would be experimental. Okay, so this one says complete a table to show the sample space when spinning the spinner shown. What's the probability that the spinner lands on 4 at least once? Well, we can also even do a tree diagram. It would actually work. However, it would get pretty busy pretty fast. So a table works out best. But you could still use a tree diagram. So you have 1, 2, 3, 4, 5 on the spinner, and we're going to spin it twice. It's implied because it doesn't tell you. But it doesn't tell you exactly, but it's just implied because you're going to spin it twice. And only because there's a table. I mean, it's not my question, but it's spinning twice. So The first time you can land on 1, and the second time you can land on 1. The next time you can land on 1, and then the second time you can land on 2. So I'm using the row, or I'm sorry, the column. So the first time I can land on 1, and the second time 3. First time I can land on 1, and the second time 4. The next first spin I can land on 1, and my second spin can be 5. So we'll repeat the same process. My first spin can be a 2, and my second spin could be a 1, land on 1. First spin, land on 2. Second spin, land on 2. And hopefully I can just keep writing and it makes sense. All I'm doing is listing what I could possibly end up with. And there's no one that says you don't. You can also do the tree diagram. It works. Which is why I started with the tree diagram. It's easy to see. But this one's just much more organized. Now, it doesn't matter if you started with the 1, 2, 3, 4, 5 from the row, because it's still going to be the same. So my first is a 5, second could be a 2, first a 5, the second spin could be a 3, so forth. So it said at least 1. And so sometimes you'll have problems like this, and it'll be dice, and it'll say the sum of, greater than 10 or whatever. And so you would add and whatnot. So just to kind of give you heads up. It says 4 at least once. So this one has at least 1 4. That's all you're doing. You're just looking for the ones that have at least 4 one time. It can be 1 4. It could be 2 4s. So let me double check myself. And what I see is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I must have messed up somewhere. Hold on. Oh, I sure did. All right, so I'm not going to re-record because I've done this way too many times. This is 5, 5. I'm not sure why I wrote 5, 4. But it's 5, 5. And maybe you caught it as you watched it. All right, so now we know 9 out of 25. There's 9 favorable amounts, which is what I want. The question is for at least 1. And so there's 9 possibilities, and the total is 25. Now, you can leave it like that. You can convert to a decimal. You can convert to a percent. All of it is fair game. All right, let's do one more. So a standard deck of cards, which is very popular for probabilities. So a standard deck of cards has 4 suits: hearts, spades, diamonds, and clubs. A card is picked and replaced. So in other words, the first event doesn't affect the second events because you're putting it back. And so you get a standard deck of cards, 4 suits, 52 decks in a card. What's the probability of a heart pulled at least once? Tree diagram also works here. However, an organized list is probably something that is easier, more user-friendly. So we can get hearts the first time and then spades the second time. Hearts the first time and then hearts the second time. Okay, you can get hearts the first time, diamonds the second time, heart the first time, and then club the second. Now I'm going to start with the spades. So get a spade first, and then you can also get a spade the second time. You can get spades with a heart, and then spades with the diamond. And then you could also get spades with the club. Now we're going to go with the diamonds. The first one can be a diamond, and the second one can be a diamond. The first one can be a diamond, and the second one can be a hearts. And so hopefully this is making more sense. And you can also do a tree diagram. It works for all of them. Diamond and club. Now we start with the clubs. So the first one can be a clubs. The second one can also be a clubs. Clubs and then hearts. Clubs and then spades, and then club and then diamond. So now it says, what's the probability that a heart is pulled at least once? Okay, so now we want to look. That has a heart in it. That has a heart, heart, heart. That's all we're doing. So there are 7. And then my total is 2, 4, 6, 8, 10. Okay, 16. And that's it. That's the probability that a heart is pulled at least once, 7 out of 16. If you have to convert to a percent or a decimal, then I have other videos that go through that. Thanks for watching. I hope it helped.